Lesson 8.2, use properties of parallelograms. In this lesson, you will find angle and side measures in parallelograms. This is for lesson 8.2. The first was to find the value of x. So since this is a quadrilateral, these angles are going to add up to 360. I'm going to do 360 minus 98 minus 120 minus 82. And I get 60. So the answer to number 1 is 60. Number 2, find the coordinates of the midpoint, AB with endpoints. Here they are. So to find the midpoint, we add the two x values. -2 plus 10 is 8. 8 divided by 2, so that's 4. And for the y value, we add 6 plus 4 is 10, divided by 2 is 5. So the coordinates of the midpoint of AB are 4, 5. Now to find the distance, we're going to use the distance formula, which means, I'll write it down here in case you still don't remember it. Basically just means take the difference of the x values, square them. So I'm going to do that. -2 minus 10 is -12. -12 squared is 144. Plus 6 minus 4 is 2. 2 squared is 4. I want the square root of that. Don't forget your square root symbol. So 144 plus 4 is 148. And the square root is 12.2 if I'm rounding to the nearest tenth. They asked for simplest radical form. Didn't tell me that. That would have been helpful. So if I go back here, 148 divided by 4 is going to be, I always try 4 because it's the easy perfect square. 4 times 37. The square root of 4 is 2 radical 37. On a quiz or a test, I would tell you which one I wanted, to the nearest tenth or simplest radical form. Is a quadrilateral with both pairs of opposite sides parallel. The term parallelogram, PQRS, can be written as this symbol PQRS. And that means in PQRS, the P and Q and the R and S are parallel, and the QR and the PS sides are parallel by the definition of a parallelogram. The theorems below describe other properties of a parallelogram. So if you have a quadrilateral and it is a parallelogram, then its opposite sides are congruent. So not only is PS and QR going to be parallel, they're going to be congruent. The fact that they're parallel is the definition of a parallelogram. The fact that they're congruent is a theorem. Also, if a quadrilateral is a parallelogram, then its opposite angles, are congruent. So there's a theorem about the fact that the sides are congruent, and there's a theorem about the opposite angles being congruent. We can use this to find values of x and y. So if you look at this problem, I can tell they want to find AB and DC are going to be equal. That means AB is going to equal DC. So x plus 4 equals 12. Subtract 4 from both sides. And I get that this side, that this x is equal to 8 because the other side is equal to 12. I also know that y is 65 degrees because they're opposite. I also could figure out, which may be something that we learn here in a minute, let me move my calculator. I could find the measure of angle D and C. Because it's a quadrilateral, the interior angles are going to add up to 360. So 360 minus 65 minus 65 is 230. That means the measure of angle B plus the measure of angle D equals 230. And since they have to be congruent, they each happen to be 115. So this problem didn't ask me to also find B and D, but I wanted to take that point to illustrate while we could here that you could find these also. Now they want you to actually go through the proof of theorem. Pull the clips. I find that on some of these the sound never recorded. Nothing like having the sound not record on a theorem. Get to go through the whole thing again. So we are proving theorem 8.3. Remember, I will give these to you as skeleton proofs, not proofs from scratch. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So I'm told that PQRS is a parallelogram. I want to prove that opposite sides are congruent. One of the things I noticed about all of these parallelogram proofs, if for some reason later in life you did have to do find FG and the measure of angle G. Well, that's pretty easy. FG is going to be congruent to HE. This is a parallelogram. You can see because the opposite sides are parallel. That's the definition. So that's 8, and G is 60. You can also use this, pull that away just so you can see that I'm right. I can check that I didn't make a silly mistake. Find the values of X and Y. Well, if this is 18, Y plus 3 equals 18. So 18 equals Y plus 3. So Y has to equal 15. 2 times what number equals 50? That's 25. So I'm going to pull this away. And I had the correct answers. Here about parallelograms. The consecutive interior angles theorem states that if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles formed are supplementary. We learned that. So a pair of consecutive angles in a parallelogram are like a pair of consecutive interior angles between two parallel lines. And that theorem 8.5 talks to that. If a quadrilateral is a parallelogram, then its consecutive interior angles are supplementary. So x plus y, or y plus x, or x plus y, or y plus x are all equal to 180 degrees. We can use that to solve some problems here. As shown, part of the extending arm of a desk lamp is a parallelogram. The angles of the parallelogram change as the lamp is raised and lowered. Find the measure of B, C, D. So we want to find the measure of that one when ADC is 110. Well, because they need to be supplementary, this is 110, this one's 70. To further go along, if this one became 150, it opened up higher, this one would be 30. And we also have theorem 8.6. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Remember, bisect means cut them into half. So you start to see we actually get a number of triangles here. There's actually 4 now. We could even get into theorems proving this triangle is congruent to this triangle and things like that. We're going to use what we just talked about in this last theorem, 8.6, that says that if a quadrilateral is a parallelogram, then its diagonals bisect. And the third video clip that did not record sound in lesson 8.2 is this problem. The diagonals of L, M, and O intersect at point P. What are the coordinates of P? Well, we learned that this point is going to bisect these. It's going to bisect these. That means that LP is going to be congruent to PN, or P is going to be the midpoint of LN. It also does tell us that PO is going to be congruent to PM, and P is the midpoint there. The book here used P as the midpoint of OM. I'm going to do P as the midpoint of LN to show you that it works. So I need the coordinates of L, which are 1, 4, and the coordinates of N, 1, 2, 3, 4, 5, 6, which are 6, 0. To find the midpoint, I add the x values. 1 plus 6 is 7, and divide by 2. So that's 7 halves. And 4 plus 0 is 4 for the y coordinates. Divided by 2 is 2. So the midpoint is 7 halves, comma 2. Guided practice for examples 2 and 3. Find the indicated measure in J, K, L, M. So first they want you to find N, M. So if K, N is 2, that one's pretty easy, and M is also 2. Now they want you to find the total length of KM. 2 plus 2 is 4. Now they want you to find J, M, L. Well, if this is 110, these are consecutive interior angles, so the entire J, M, L is going to be 70. And K, M, L, if this is 70, then that's 40. We also could use trigonometric ratios to find these lengths, to find other lengths within the triangle, and then get the parallel. Homework quiz. Find the values of A and B in the parallelogram. So since we're told this is a parallelogram, these sides are parallel, they're also congruent. If this side is 30, then 30 is equal to A minus 12. Add 12 to both sides, and you get A equals 42. Oh, I forgot to do the last one. Well, you know